properties of logs. I'm going to remind you of properties of exponents, or a few of the exponents. So if we have b to the 0 power, um, anything to the 0 power always equals 1. So b to the 0 equals 1. Well, remember, if we rewrite this in log, it would be log of base b of 1 equals 0. So in all of these properties of logs, it's the exponential properties just rewritten using log. So remember, and I'm going to remind you of one more. So if we have b to the n times b to the m, we just write it as b, and when we're multiplying and we have exponents, we just add them. It'd be n plus m. So the log property, we're going to rewrite this. So the log property, and I'm going to write it in red, is written as log base b of n times m. So n times m, if you're multiplying the exponents, because the base n times n, then it's the same thing as log base b of n plus log base b of m. So that's just a reminder. I'm going to write these out a little bit prettier. I just wanted to remind you that exponential is just logs rewritten. So let's go ahead and we're going to write out all of the log properties. So if we have log base b, remember base b is just the base, of 1 equals 0. Then if it's log base b of b, that's equal to 1, because that is the base raised to the first power equals b. Well, anything raised to the first power is always b. Okay. Now we have log base b, and this is the one that we just wrote, of n times m is the same thing as log base b of n plus log base b of m. So if you're multiplying logs, it's the same as adding. So this is called the expanded version because notice it's expanded. This is the simplified version, I guess you could say. So sometimes it's going to ask you to expand it, and then sometimes it's going to say simplify it. So that's just asking you to go back and forth. Okay, then we have log base b of n divided by m. And that's the same thing as, well, if you look at multiplying as adding, then if you divide, then you're going to subtract. And that's the same thing as whenever we were working with exponential and we were simplifying when they were on top, we subtracted the exponents. So we subtract. So if you're dividing logs, you can subtract. Okay, then if we have log base b of n to the m power, so raised to another power, it's the same thing as, you pull that out front, and it would be m times the log base b of n. So example 1, so let's actually apply this. So if you have log base 5 of 4 plus log base 5 of 3. So notice, in order for these logs to work, if you notice they all have the same base. So if it's log base 5 of 4 plus log base 5 of 3, it's in expanded form, so I need to move it to simplified. So notice when you're adding logs, it's the same thing as multiplying. So I'm going to write it as log base 5 of 4 times 3. Well, 4 times 3 is 12, so I would have to rewrite it as log of 5, log base 5 of 12. If you type that in your calculator, if you type this in your calculator, you're going to get the same thing. So if I type in, and remember to write the write the log with a different base, you have to hit math, go down to this one. So it'd be log base 5 of 4 plus, I have to do it again, log base 5 of 3, and you get 1.54. Now let's type in the simplified version. Log base 5 of 12. Notice it gives you the same thing. Obviously if there were variables, like if this was 4 and this was x, you wouldn't be able to just type it in to see if it's correct. But anytime it's all numbers, you can always type it in your calculator to see if you simplified correctly. And whenever I say to simplify, I don't mean give me the decimal answer. It means to just rewrite it. Okay, so let's do another one. 2 log of x equals 3 log of y. Well, in order to rewrite this, it cannot be equal to. We need them to either be plus or minus. So I'm going to have to move one of them. So I'm going to move, it really doesn't matter. So I'm going to have to move one of them. So I'm going to do the 3. So I'm going to subtract 3. And I'm going to subtract 3 log of y. Now, I cannot combine these because I cannot combine an x and a y. Just like if I just had a plain 2x and 3y, I couldn't subtract those because they have different variables. So it's just going to be written as 2 log of x minus 3 log of y is equal to 0. Okay, now look at your rules. We have numbers out in front of the logs. So if you have a number out in front of the log, it becomes the exponent of that number there, or that term there. So then this 2 becomes the exponent, the 3 becomes the exponent there. So then it would be log of x squared minus log of y cubed equals 0. Okay, we're still not done. Now if you look at this, we have a subtraction sign between them. So when you're subtracting, it's the same thing as dividing. So I'm going to write it as log. It's going to end up being division. The first one goes on top, so it'd be x squared, and then the divided by the second one, so y cubed equals 0. So that is the final simplified version.